Hello everyone, and welcome back to our video series on precision battery test solutions. In this video, we'll discuss the battery voltage sensing IC. You will need to consider your system needs and design goals when selecting for this socket. Remember that the unit will be monitoring your battery voltage, and its output will determine when the safety, regulation, and threshold protections kick in. Also consider that while most batteries may charge slowly, which might lead you to think very little bandwidth is needed in this socket, if your system needs to measure impedance via charge injection, you'll need high bandwidth in this socket to accurately measure the quick shifts in battery voltage that will arise from the injected current. This socket can be implemented with an I&A, a precision amplifier in a buffer configuration, or by a difference amplifier, depending on your accuracy needs. It should be noted that for most BTS implementations, 4-lead sensing is used instead of local or 2-lead sensing. This means that instead of measuring the battery voltage using the same leads that are utilized to charge or discharge it, independent sense leads are monitored instead. Without this, an offset that is a function of the charge-discharge current and connection parasitics will appear. With independent sense leads, the only apparent offset is that across the current limiting resistors due to the input bias current, and this can be addressed via calibration. Once again, the drift will play a major role in determining what accuracy the system is able to achieve. The offset of the amplifier will result in an immediate inaccuracy, but can be calibrated out. However, the offset can drift with temperature, resulting in discrepancies that cannot easily be calibrated out. The CMRR of the amplifier will also play a small role, as the error equation shows. In this socket, however, perhaps the most important spec is the input bias current. If the IB is high enough, the amplifier can actually leach current from the battery. This will reduce the accuracy of the current measurement IC, as some of the current that passes through the shunt will be redirected into the sense amp. Don't make the mistake of investing in a precise current measurement IC only to have much of that charge current get wasted by the battery voltage sense IC. The offset current can be a significant determining factor for this socket as well. In our hardware testing, we experimented with both an OPA 188 and an INA 188 in this socket. However, depending on your system needs, you may want to utilize a different device. Visit the Precision Amplifier section on TI.com to view and compare different devices. Thank you for your time. Please visit TI.com for more information on battery test systems and other useful resources.